Okay, this is, I'm going to say, somewhere between HL and SL. I think this is really an HL question on kinetic energy. However, I think it's one that SL could do. If you want to give it a try, feel free. If not, feel free to skip it. Okay, we've got satellites X and Y with the same mass and they're orbiting a planet. We know the orbits of the satellites at a scale, and we want to know their kinetic energy ratios. As usual, have a second to try the question, and when you've had a go or you're not sure, watch on the rest of the video to see the explanation. Okay, so in this case, we're going to use the fact, obviously, that we've noticed here that our radius of orbit are linked by a factor of 2. Now, this is something just worth mentioning. A lot of students will make the mistake here, as I have done in previous videos, I'm sure, of measuring from the surface of the planet. In this case, we measure from the center. So you can see here that Rx is 1, 2 blocks, and then Ry is 1, 2, 3, 4 blocks. And so therefore, Rx is half of Ry, and that's going to be important for later, because we're then going to determine the kinetic energy. Now, kinetic energy, as we know, is a half mv squared, but we're going to use a very common trick, and this is one that I've done in previous videos, to use our forces to get our half mv squared. All we're going to do is say, well, mv squared over r is equal to gmm over r squared. This is our force balance, where we say that the gravitational force provides the centripetal force. That's a really common sort of tool that's used in these questions. You could use this, for example, to derive one of Kepler's laws, Kepler's third law. Why is that important? Well, we can cancel that r on the bottom and just divide it by 2. So we get Ek is a half mv squared. Well, mv squared over r is this. Take away the r. mv squared is gmm over r. mv squared over 2 is just gmm over 2r. Now, why is that important? Well, we can now take the ratios. The ratio of the kinetic energy of x is simply going to be a ratio of this number for both. And you're going to find that we go opposites. Kinetic energy of x over kinetic energy of y is a ratio of ry over rx, because it was 1 over r dependence. And therefore, ry over 2, as determined at the beginning, gives us a factor of 2, which means the answer here is 2. That ry has got object y has twice the kinetic energy of object x.